purpose of this product training module is to educate designers and prospective customers on the differences between SLC and MLC-based NAND flash architectures. NAND flash storage solutions have vastly different performance capabilities depending on the type of NAND architecture that is utilized in the device. Certain applications, such as those that have high shock and vibration or extreme temperature considerations, will require SLC-based NAND flash storage solutions for best performance. This presentation will help the designer understand the different performance features that can be expected when utilizing each NAND-based architecture. NAND flash. NAND flash also uses floating gate transistors, but they are connected in a way that resembles a NAND gate. Several transistors are connected in a series, and only if all word lines are pulled high above the transistor's VT is the bit line pulled low. These groups are then connected via some additional transistors to a bit line array. Writing and erasing. NAND flash uses tunnel injection for writing and tunnel release for erasing. NAND flash memory forms the core of the removable USB storage devices known as USB flash drives, as well as most memory card formats and solid-state drives available today. Today, 3 types of NAND flash exist. The main difference for storage application is based on the reliability performance of endurance and data retention. The number of internal references levels double with each technology jump. This is a comparison sheet for the 3 types of NAND flash technologies from the end of 2012. This outlines the density ranges and performance features such as reliability, durability, data retention, endurance, error correction code capabilities, operating temperature ranges, product lifestyle, bits per cell, and the design geometry the die are produced on by NAND suppliers. This data retention graph shows a big impact of shrinking geometry on the endurance level. In other words, the smaller the source die becomes, the more challenging it becomes to maintain endurance within the device. Flash endurance is affected by writes to the NAND cell. The threshold voltage level shifts as the NAND cell ages. Each write and erase process damages the floating gate. The key factor in the design differences between MLC and SLC NAND flash is the controlling write and read circuitry for all cell locations. Because of the increased VT range for valid states between a 0 and 1 for SLC operation, the endurance and data retention increases significantly. Specifically, this occurs as follows. A voltage difference between the drain and the source VD, Vs, creates an electric field between the drain and the source. The electric field converts the previously non-conductive poly-Si material to a conductive channel, which allows electrons to flow between the source to the drain. An electric field, caused by a large gate voltage, Vg, is used to pull electrons from this conductive channel onto the floating gate. This gate voltage gives the electron enough energy to be pulled onto the floating gate. The number of electrons on the floating gate affects the threshold voltage of the cell VT. This effect is measured to determine the state of the cell. Over time, the floating gate retains more and more residual electrons, charge trapping, which will shift the threshold voltage higher. As this VT becomes higher, the proper level detect range also becomes smaller. With SLC, the threshold level shift is not as critical and leaves more margin. Thus, SLC NAND has better endurance reaching about 100K PE cycles. With MLC, the level shifts across the threshold earlier, making the endurance of MLC NAND much shorter, about 1K PE cycles. With SLC NAND, a 0 or 1 is determined by the threshold voltage of the cell. The threshold voltage can be manipulated by the amount of charge put on the floating gate of the flash cell. Placing a charge in the floating gate will increase the threshold voltage of the cell. When the threshold voltage is high-end, around 4.0 volts, the cell will be read as programmed or a 0. No charge in the floating gate or threshold voltage of 4.0 will cause the cell to be sensed as erased or a 1. So, as charge trapping occurs, it becomes more difficult to erase the cell. As previously seen in Figure 1, a flash cell's ability to store charge is also why MLC technology works. Since the range between each bit cell has decreased for MLC, the sensitivity to an accurate read also increases. Thus, more rigidly controlled programming is needed to manipulate a more precise amount of charge stored on the floating gate. In order for a flash cell to be considered MLC technology, the cell must exhibit two characteristics. 1. Precise charge placement. 2. Precise charge sensing. Thus, MLC flash works the same way as SLC flash, but the threshold voltage must be more precise to manipulate the state of the flash. Once again, the amount of the charge on the floating gate is what determines the threshold voltage. With each write and erase, the floating gate wears out because it will retain more electrons over time. The effect of this reduces the ability to detect proper MLC levels and eventually the ability to erase the cell and ultimately the retention of programmed data. As you can see by this graph, SLC is more stable and less prone to data retention errors. This makes SLC NAND the architecture of choice for high reliability NAND memory solutions such as those produced by Swissbit. These memory solutions are most often utilized in applications where reliability, endurance, and being able to perform under extreme conditions such as high temps, shock and vibe, or dirty and wet environments exist. MLC NAND is most often utilized in consumer applications, where cost per bit is the major factor in the design, and endurance and reliability are not as important. In conclusion, both MLC and SLC NAND architectures have strengths to their respective designs. These include cost per bit, longevity, reliability, and endurance of the device. Utilizing the correct architecture of NAND in the right end product application is key when considering a NAND memory storage solution. Both SLC and MLC are subject to NAND cell damage over time as reads and writes occur, but utilizing SLC NAND and partnering with the highest performing controllers and firmware solutions available, Swissbit builds some of the industry's highest performing and most reliable NAND-based memory storage solutions available in the market today.